And everyone should submit the weekly homework because some of the students did not submit till now. Friday, the question, like example, a question in which you have doubt, you're not able to answer it, leave that, but you have to attempt or try to solve the one which you are able to answer and submit. Instead of sending a PDF, because sometimes PDF is taking too much time to load. So better just take a picture in sequence and send it to me so I can check your progress. The topic is about method of purification or separation techniques, how we can separate the substance or how. First thing, how you identify whether a substance is pure or impure. So how you can identify whether a substance is pure or impure? Pure substance contain identical particles. So when identical particles are there in the substance, we call that as pure. An impure substance contain mixture of the particles. So example, if I say I have a container, this container is filled with H2O molecules. And all of them are H2O molecules. So what I will say, this is a pure substance. Why I will say it's a pure substance? Because it contains identical particle. And whether this is an element or a compound, this H2O is an element or a compound?
Compound.
Compound.
H2O
Sir,
or water
it's a
is an
compound.
element or it's a compound? H2O is a compound because it contains two or more different, in this example, it contains two different atoms. So this is a compound. But it's a pure compound. Why we call it a pure compound? Because it has identical particles or identical molecule. Same thing. Same thing if I say O2. This substance is pure or impure?
Pure.
Yeah, so it's pure. And whether it's an element or a compound?
Element.
Yeah, pure and it is an element. So when you have identical particles, you call that as a pure substance. If particles are group of atoms, we call that as a compound. If particles are different atoms or molecule, if identical atoms or molecule, you will call that as element. But what is impure substance which contain different types of particle? Like example, you add a salt to water. So when you add salt to water, what happens? The salt
Fluid.
example, you add sodium chloride, NaCl, and H2O. So if a substance contains different types of particles, then that substance is refers to impure substance. So it will become impure. And if there is no chemical combination, like NaCl is not chemically combined with H2O, what we call, if there is no chemical combination between the substance, so we will call that as a mixture. Sodium chloride and H2O are not chemically combined together. So this is a mixture of sodium chloride and water. And mixtures are always impure because mixture means it's a combination of two or more substances. Then how you can check the purity? If you want to check whether a substance is pure or impure, there are three ways to check the purity. Number one, you can check its melting point. If substance is solid. If a substance is solid, you will check the melting point, because pure substance, I will explain what happened, what will the effect if a substance is impure. Just I'll mention first the things which you will do. So you will check first the melting point of a substance if you want to check the purity. Or you can check the boiling point. If it is liquid. Yes, Abdul Rahman?
Mister, what's the benefit of checking these things?
Can you repeat, Abdul Rahman, what you're saying?
What is the benefit of checking these things?
Just a minute. I think can you say again, Abdul Rahman?
Mister, can you hear me?
Yeah, I can hear you now.
Okay. What's the benefit of checking these things like boiling and melting points?
Because if a substance is pure, it will boil at fixed temperature. If it is impure, it will boil at a range of a temperature. So what is the advantage? Why we check? Because some of the reactions, like some of the chemical reaction, if you use impure substance, you will not get the desired amount of product. So that's why you should always know, like, what is this, whether a substance is pure or impure. Clear?
Yes, please.
And the third one, you can check you can check the melting point, you can check the boiling point, or you can check or use chromatography. You will learn this technique in detail. If liquid, or it can be used for paste. In detail, I will explain all these. Anyone want to take the screenshot can take now, so I'll move on to. I will explain these statements. Like, if you want to check whether a substance is pure or impure, you will check the boiling point, you will check the melting point, or you can use a technique which is called a chromatography. So example, what is the effect of impurity? On melting point. So what is the effect of impurity on the melting point? Impurity lower the melting point. So example, you have two samples of ice. You don't know which is pure and which one is impure. And you're supplying the heat energy and measuring the temperature for each sample. You observe that this ice start to melt at -4 degrees centigrade. It start to melt when the temperature was. This ice start to melt at 0. Which of the sample is impure, A or B?
B.
Which is impure?
B.
B is impure. My question is, which of the sample is impure?
A.
A is impure because you can see here the effect of the impurity on the melting point, so it will lower the melting point. So if the substance is normally the pure ice melt at 0, but if it is impure ice, it will melt at lower temperature or below 0 because the 0 was a melting point of ice, pure ice. So because it is melting at -4, so it is melting at a lower temperature. So sample A is impure, where sample B is a pure sample. Is it clear? So whenever reason is there, you will learn that in physics, like why the substance is, if it's impure, then it is not melting at the same temperature as a pure substance. And it is not necessary that it will melt at a specific temperature. Maybe it, because this melting temperature depends on the amount of the impurity. So it's not necessary if impure ice is there, it will always melt at -4. It may melt at -2 as well. So if it is melting at -2, that's also not the melting point of a pure ice. So you can conclude, or you can say that this ice is impure, or sample of this ice is